Okay, we are going to move on now to essential question. How can we use substitution to solve a system of equations? And notice that it's right here in this little square right here. Okay, I'm not going to keep that up long. I'll keep it up for a minute, maybe as I'm talking. If you don't get it, then you can always rewind the video to get it, or pause it while you're writing it down. But now I am going to eliminate it so that it doesn't take away from my space. So again, and I won't do this again, we're in 5.2. How can we use substitution to solve a system of equations? So far we've been graphing and finding where that one point is. But to be honest, that is probably the most time-consuming way to find the solution to a system. For instance, what if your points are like way up here, and this is negative 700 and, well, positive 721 comma 325. Well, are you going to really want to graph that? And are you going to want to make a graph that big? No, that would not be the best way. Also, there's a good chance maybe you graphed wrong. And so you didn't get the right answer because you actually graphed incorrectly. Let's see what else. There's a more productive way, an algebraic way. We started with the visual so you understood what a solution was. It was a point that was true for both equations. It's the intersecting point. We know that parallel lines have no solutions because there's not one point on one line that's the same as the other. And whereas parallel lines, excuse me, has no solution, coincident lines have every single point in common, so they have an infinite amount. So we're going to start with the substitution method, and there are two ways to present it. One way is that you have these two, and what our goal is to make one equation. One equation, so it's like I'm going to smash these up. Now, what's nice about this way is I already have an x that's already by itself. It's already isolated. So this here, x equals 17 minus 4y. So this is its other name. So I'm going to take this value, I'm going to plug it in there. And I'm going to do this on the whiteboard. So x is by itself. It says x equals 17 minus 4y. But I want to plug it or substitute it in to this x down here. So what I did was I put a parenthesis around here and I put a parenthesis around there. It kind of makes it a little bit easier. So let's go ahead. Actually, I'm going to do one more line on here. Okay, here we go. So this is going to become y minus. I bring down the y and the minus. Now it has a parenthesis, but I'm not going to put x. I'm going to put this new name here. 17 minus 4y. I'm going to close the parenthesis. Close the parenthesis. I'm going to put the equal sign. And I'm going to put -2. So I took two equations. I squished them together. And I made one. How did I do that? I did it by taking this value of x and plugging it in here. So that's your goal. Also, goal 2 is, do you notice that there's only one variable right now? I had x's and y's, but now there's just y. By substituting in this value for x, you eliminated the x so that we might be able to solve for y. So let's go ahead and let's solve for y. There's a minus sign outside that parenthesis, so that means either we want the opposite of everything in here, or you are distributing a -1 to both inside. Okay, so I simplified that. Let's go ahead and collect our y's. And so now we know how to do this. Some multi-stepped. I'm going to remove the 17 first, eliminate it by adding the opposite. I have 5y equals 15. And now one last, I hope I can fit under here. I divide both sides by 5, and so y equals 3. So I have half of my work done. I found out what y is. What will x be? Well, let's see. Let's look at this first one here. It says x equals 17 minus 4y. Well, guess what? We know what y is now. So x equals 17 minus 4 times 3. X equals 17 minus 12. X equals 5. So where these two original lines cross, they cross at the ordered pair 5, 3. Now, can we prove that this is correct? Yes, but I'm not going to do it here. I always suggest you check your work, so you would just go in like we did before. Is this ordered pair a solution for this system? And you would plug in the values 5 and 3. It has to be true for both since they are a system. So what do you think? It's pretty good. Okay. Why don't you do one right now? And I'm going to take a minute here. I'm going to move this. I'm going to erase this. Now, at this point in the video, you should hit pause. You should hit pause. Why? Because you're going to try to do this on your own. Remember, it's like riding a bike. If you always have your parents behind you, or if you always have the training wheels on, you're never going to learn how to ride, right? So it's kind of how math is. If you don't try to do it on your own, you're never going to learn. So let us look at this real fast. So pause it now. Try to do it on your own. Or if you want just kind of a little hint to start off with, I will go ahead. This one has a variable all by itself isolated, so it's all ready to go into substitution. So it's saying that x has another name. X is also 6y minus 7. So I'm going to plug in this value here into this parenthesis here. Okay, just like we did on the first one. Okay, so pause, try to do it on your own. I, though, am going to keep going and I'm going to solve it. So I'm going to rename this 4 times x. Notice that my arrow is pointing down here, so I'm taking this and putting it in here. I'm going to rewrite the 4 because I'm not doing anything to it. But I'm no longer going to put x. I'm going to put its new name, 6y minus 7 close the parenthesis, plus y equals -3. I've taken two equations that have both x's and y's. I've compacted it. I've smashed it into one line, one equation, and notice that there's no x's. So now let's distribute. So I distributed, remembering to distribute to both the 6y and to the -7. I have two sets of variables, so I'm going to add those together. 25y minus 28 equals -3. So what do we remove first? We remove the integer or number that's furthest away from the y, the one that's indirectly connected. So we're going to add 28. We're going to add the opposite. We're going to do the opposite process. 25y equals, well, 28 minus 3 is 25. And if you divide by 25 on both sides, you get, let's see, I'll put it over here, y equals 1. So I was able to solve this. I was able to find out what y was. But now I'm going to go back up here to this original problem up here. X equals 6y minus 7. And I'm going to take that value and I'm going to plug it into the y. X equals 6 times 1 minus 7. We're evaluating this, so we're substituting in. Don't be skipping steps. X equals 6 minus 7. So x equals 7 minus 6 is 1. The 7 is the larger absolute value, so it's going to take that sign. So where this line intersects, its solution is -1, 1 in parentheses. This is a destination on your coordinate plane. Did you do okay? Did you get it? With practice, we will get better at it. I like the substitution method, but we're going to be doing the elimination method next. That's 5.3. I always like the substitution method. So many people, so many kids, students, they, oh, I hate it. And I go, why? Okay, so in these two examples I gave you, there was a variable isolated, so it was all ready to go. Well, guess what? It's not always that easy. So take a look here. I have an 11x minus 7y equals -4. And I have an x minus 2y equals -4. Oh, -14, sorry, and -4. So I have to manipulate. I have to do an extra step to get myself a variable by itself. So you have three choices. You have 11x, but when you move over the -7, you're going to have to divide by 11. You're going to end up with a bunch of fractions. -7y. I could move the 11x over there, but again, I'm going to end up with this really weird equation. I have a -2y, but this here being a variable that stands alone, so the only thing there is a 1, is always always where you want to go. So I'm going to change this line here to become something that looks like this here. So I'm going to add 2y to both sides. And I end up with x equals 2y minus 4. And now I have a variable all by itself. So let's take, there's my red. So here we go. So now I'm going to go ahead and I'll write this problem right underneath. So it's kind of right next to each other. So I just took this and rewrote it down here. okay? So I have an x equals 2y minus 4. I'm going to plug this in right here. X has a new name. It's not x, it's going to be 2y minus 4. So let's see what we get. I'm going to rewrite the 11. Oops, oh, I know why I'm getting so far down, because I'm starting so far down. So I'm going to get the 11. I'm going to do a parenthesis. I'm not going to put x. I'm going to put the new name, 2y minus 4. Close the parenthesis. I'm going to bring down the negative 7y equals negative 14. I've taken the original two questions, this one, or equations. I've taken the two original equations. I changed this one up a little to make it so that it is a variable equaling. Then I took these two, I collapsed them together, I smashed them together, I compacted them together, I eliminated the x. So now I have an equation with only one variable, and I can solve for that variable. So let us distribute. I'm only doing one thing, I'm only distributing. I'm not thinking ahead, I'm not skipping a step. My next step, I have two like terms. I have y's. So I want to collect them together. And now, what do I want to get rid of? This here. It's an addition. Now I get 15y equals, and now maybe I'm a little confused here. I'm not going to use a calculator. I'm going to come over here. I'm going to take the larger absolute value, the 44. I'm going to subtract the smaller absolute value, 14. I end up with 30. And then I look back. The 44 is the larger of the absolute values. It's a positive, so that's going to be a positive 30. I'm going to divide both sides by 15. And now I have y equals 2. And there you go. Now you could go back into this equation here, which is y equals 2y minus 4. I'm going to substitute in the value, so 2 and y is also 2 minus 4. X equals 4 minus 4. X equals 0. And 0 is a value. You know that 0, you have 0 zeros is your origin. So this is at 0, 2. So this line happens to cross on the y-axis. Okay, are you good? So at this point now, I'm going to give you a problem to do. So I'm going to place it down. Now you could do one of two things. You could stay for a little bit of a hint to just get started, or you could pause me right now and try to do it on your own. Okay, so those of you who are going to stay, stay. Those of you who are going to pause me, pause me. Okay, so here, when we talked about here, this wasn't a good choice. This wasn't a good choice. This wasn't a good choice. This was really the only choice. But right here, I gave you one that has this is a good choice, this is a good choice, and this is a good choice. Whatever you choose, it will work. So I'm going to go ahead, and I think I'm going to take this here. I'm going to take the, I think I'm going to do it down here. I'm going to add 3x to both sides. And when I add 3x to both sides, these cancel. I get y equals 3x plus 6. So now I have a variable all by itself. I'm going to bring this one down too. So x plus y equals negative 2. So here's my system. I have myself an isolated, so y equals this, so I put a parenthesis, 3x plus 6, and I'm going to plug it into this y here. I'm going to make an arrow. Do you have to do the arrow? Well, no, but you remember that your notes are an extension of me, and they should be as detailed as possible. So everything you put into your notes will only help you to do better. So let's go ahead and plug these in. So I have the x, not doing anything with the x. I have the plus sign. I have the parenthesis. Now I'm going to put 3x plus 6 equals negative 2. Did I really need to put that parenthesis there? Not really, but it kind of helps me know I'm putting what's in this parenthesis, I'm substituting it into that parenthesis. So I have an x, a 3x, and a 6. So I have 4x plus 6 equals negative 2. I'm going to subtract 2 from both sides, 6 from both sides, sorry. 4x equals, these are both the same sign, so you just collect them together. 6 and 2 is 8, but we're talking about negative numbers. And now you divide both sides by 4, and x equals negative 2. So now you've got that. So now what do we have to do? We have to go back up here. We found x now. Let's find our y. Y is 3x plus 6. So we're going to substitute in negative 2 for our x. So y equals 3 times negative 2 plus 6. Y equals negative 6 plus 6. So y equals 0. So we have another 0. He's happy. We're using them. So I put a box around it. Do not forget to write your ordered pair. An x and a y, the comma in between, and then parentheses. This is a destination. If you just give me this and this, I will take points off. This is you solving for x. This is you solving for y. But the answer is this ordered pair that happens to be the same thing for both x plus y equals negative 2 and negative 3x plus y equals 6. How are you doing? Is that a lot? A lot to take in? Want to try one more? 2 more? We'll do 2. Okay, let me erase this. So I'll do one of each again. So you will take notes on these. These will be due on Monday. And then we'll do activities utilizing what you learned from taking these notes. So this is like the first one. And it already has a variable already isolated and by itself, ready to be plugged in to the variable down here. So again, I'm going to put there. So I gave you a hint. If you'd like to pause right now, go ahead and pause so that you can try to do it on your own. If you want to do a couple of steps and start the video again, see if you got it, good, got it, pause, and then keep going. So I'm going to blend these together. So it's going to be 6x minus sign 5. I don't like this pen. Sorry. Minus 5. Now, I have this y here. So I'm not going to put y. I'm going to put its new name. It's negative 2x minus 9. Close the parenthesis. I still have an equal sign, and I still have a negative 19. Two goals. One goal is it's all in one line. Second goal is you only have one variable. So this time we have our x's. So now let's go ahead and keep going. So I have 6x plus 10x plus 45 equals negative 19. Now how did I get that? Negative 5 times negative 2x. Negative times negative is a positive. 5 times 2 is 10. And of course we have our x. And the same thing here. A negative 5 times a negative 9 is a positive 45. So let's go and collect. We have 16x plus 45 equals negative 19. So what are we going to do now? We're going to get rid of and move. Trying to isolate this x. So we're going to move this first. So do the opposite. Oops. Sorry. I don't know why I wrote 14. 45. Okay, so that means that these cancel. I'm left with 16x equals, and again, sometimes it's not best to do it in your head. So I have 64. Oh, wait a minute. No, I don't. My bad. Oh, yeah, I do. Sorry. 45 and 19 because they're both negatives. So we're going to add them together and we get 64, but it is a negative 64. So negative 64. Unless you know your times tables to this, it's kind of a hit and miss. If I were to divide, let me do it down here. If I were to divide 64 by 16, I'd go, let's see, 16 times 16 is 32, and you work it, but it happens to be a 4, so it goes in 4 times. So there you go. So now we're going to go back up here because we know our x, but we want to find our y. So let's get our y. Y equals negative 2x minus 9. I like to rewrite the problem. Keeps it neat, keeps it organized. Now I'm going to plug in the value. Negative 2 times negative 4 minus 9. Y equals 8 minus 9. 9 is negative, 8 is positive. You subtract, and you take the sign of the bigger absolute value. So y equals negative 1, and there you go. Don't forget to write your answer as an ordered pair. And that is where those two lines cross. This solution will make this a true statement, and it will make this a true statement. Okay, I got one more for you. Okay, this one doesn't have a variable by itself, but it does kind of have a tricky one. So you might want to hang out for just a little before you pause it. I don't know, maybe, maybe not. Okay, I don't want to do the 2x, I don't want to do the 3x, but I have these two y's. So let's just do this one because it's closer. So I'm going to subtract 3x from both sides, and I get negative y equals negative 3x plus 1. Now, this y is not isolated yet because this y happens to have a negative 1 in front of it. So you actually have to do one more step, which is to divide by the coefficient in front, which is a negative 1. And then you get y equals 3x minus 1. We're not solving for a negative, we're solving for this. So now this is our new, I'm going to kind of do it over here. I'm going to rewrite these now. So y equals 3x minus 1, and we have 2x minus y equals negative 5. Okay. Maybe now you want to pause, try to do it on your own. Remember, we always have to try. Okay, so this is y equals this. Where's my y? It's down here. So I'm going to substitute it in there. So I'm going to write the 2x. I'm going to write the minus sign in the open parenthesis. I'm going to plug in the new name, 3x minus 1 equals negative 5. Goal 1, I have 1 line, not 2. Goal 2, I only have x's. So yay, yay. So I'm going to distribute. Now remember, there's a negative 1 here, so you could think of it as you're distributing a negative 1 to everything. Or you could think of it as, I want the opposite of everything that's in there. So it's a negative 3x and a positive 1 equals negative 5. I'm going to collect these together. 3 minus 2 is 1x, but the 3 is the absolute value is bigger, so it's going to be a negative 3. Plus 1 equals negative 5. Okay, subtract 1 from both sides. Negative 1x equals negative 6. Again here, don't want to know what negative x is. I want to know what x is. So I'm going to divide both sides by the coefficient, and I end up with x equals 6. So now I got my x. So I'm going to come over here and go to y equals 3x minus 1. So y equals 3 times whatever x is. We found out that x was 6 minus 1. Y equals 18 minus 1. Y equals 17. Good job. So my answer is 6, 17. X and y, in parentheses, a destination. We will find this on the coordinate plane. Okay then, we're done with substitution, just the math part, not including any of the applications or word problems. So these notes, I would like them completed by Monday. I am going to go into solving by elimination, just the math, and then we'll do a section of both with the applications and the word problems. So there you go. Hope you did okay.